All right, this is Trig lecture 210 to 11. The student will use angle, sum, and difference identities to find exact values of a given trigonometric function. What we're going to do is use these formulas. Right here, sine, cosine, there are two of them, tangent, there are two of them. And these angles in here are going to be special case angles, 30, 60, or 45 from the special case triangles. Or, so this will either be a 30, a 60, or a 45. Each one of these variables will be either 30, 60, or 45, or an angle whose reference angle is 30, 60, or 45. Okay? So that's what we're going to be doing. We're going to be using these formulas. Here's a hint. Rewrite given angles, the angles that are given to us. They'll ask us to evaluate the tangent of some angle. We'll rewrite that angle as the sum or difference of 30, 60, or 45 degrees, special case, or an angle whose reference angle is 30, 60, or 45 degrees, and then apply STC where necessary. In other words, all trigonometric functions are positive in quadrant 1. In quadrant 2, only the sine and its reciprocal are positive, the rest are negative. The tangent and its reciprocal are positive in quadrant 3, the rest are negative. And the cosine is positive in quadrant 4, its reciprocal is as well, all the rest are negative. So we're going to keep that in mind and reference angles if we need to. So here we go, let's take a look at this. Here are the special case triangles I'm talking about. So if I say the sine of 30 degrees, I'm going to be talking about 1/2. Cosine is radical 3 over 2, etc., etc. So here we go. We're going to use sum and difference identities to find the exact measures of each. This sine 105, I'm giving a little hint here. This can be thought of as the sum of two special case angles. I'm going to say, hey, well that ends in a 5, so I'll bet you one of them is 45. The sine of 45 plus what? Well, 45 plus 60 is 105. So there's my two special case triangles. There they are, right there. And I am going to think of, this one is U, and this one is V, and I'm going to use this pattern right here. I was nice enough to bring that down for you so you can watch this. The sine of U plus V is sine of U. That would be the sine of 45. Times the cosine of V. That would be the cosine of 60. These are degrees, by the way. Plus the cosine of U. That will be the cosine of 45 degrees. Times the sine of V, which will be the sine of 60. And I'm going to make these substitutions using my special case triangles right here. Make substitutions here and do the arithmetic. Sine of 45 degrees is 1 over radical 2. Quickly, I'll rationalize that denominator. Multiply top and bottom by radical 2. This is old school. Your calculator will do this. This gives me radical 2 over radical 2 times radical 2 is radical 4, which is 2. So from now on, when I find my ratio to be 1 over radical 2, I'm going to write radical 2 over 2 because I want my denominator rational. Your calculator will do that. If you go 1 over radical 2, it'll tell you radical 2 over 2. So we got the sine of 45 degrees. That is 1 over radical 2, opposite over, oh wait a minute, oh there, 1 over radical 2, that's radical 2 over 2 if I rationalize the denominator. Times the cosine of 60, that's 1/2. Plus, the cosine of 45 degrees is adjacent over hypotenuse, that's 1 over radical 2, which is the same thing, I just did that, radical 2 over 2. Times the sine of 60 is opposite over hypotenuse is radical 3 over 2. And now I've got just a little bit of arithmetic to do. This, I'll get rid of this scratch work here, I don't need that anymore. Radical 2, remember when you're multiplying, we follow the order of operations, we're going to multiply first and then add. So if we're multiplying fractions, we multiply the numerator times the numerator. Radical 2 times 1 is radical 2. 2 times 2, we multiply denominators, is 4. Plus, radical 2 times radical 3, you can multiply under the radical. That's radical 6. as long as the indexes are the same, the indices. And 2 times 2 is 4. And these have a common denominator, so I'm going to add my fractions. Radical 2, we add the numerators, radical 2 plus radical 6, and it doesn't matter what order these are in. Radical 6 plus radical 2 is the same thing as radical 2 plus radical 6, because addition is commutative. If this was a minus sign, the order wouldn't matter, but it's a plus sign, so we're good. And we add the numerators and we leave the denominator the same, and that gives us the sign of whatever it was we were looking for, 105 degrees. Okay. So there we are, and we would be looking for this value in a multiple choice setting, and I'm going to check to see if that's right. If it isn't, I'm going to cry. I guess it would help if I had the right answer sheet. Radical 2 plus radical 6 over 4. And remember, if there's a plus sign here, the order doesn't matter. 2 plus 3 is equal to 3 plus 2. Radical 2 plus radical 6 is the same thing as radical 6 plus radical 2. We could have called this 60 plus 45, and these two would be reversed, but the value would be the same. Okay. If it was a minus sign, that would not be the case. Here we go. I did another example, and I'll leave this up long enough for you to freeze this. If you want to refer to using this, I thought of negative 15 degrees as, I said, hey, it just popped into my head, 30 minus 45, those are special case angles. 30 minus 45 gives me negative 15, and then I went through everything I just went through above. There's the sine, cosine, minus, cosine, sine, did the arithmetic just like I did above, and I came up with the right answer. So hopefully that makes sense. You can look at it, and if you have any questions about that, it's just like the one above, except there's a minus sign. If you have any questions, you can ask me in class. Let's look at the cosine. Here's one that's cosine of 195. Again, this ends in 5, so I'm going to think, well, one of my angles is 45. Plus, this would be, if I subtract 45 from it, I get 150. Now, here's what I'm thinking real quick. I want to find the reference angle of 150 degrees. That's what this instruction up here meant. The hint, rather. Rewrite given angles as the sum or difference of 30, 60, or 45 degrees, or an angle whose reference angle is 30, 60, or 45 degrees. So I'm saying, well, I'm going to find this reference angle and see if it's 30, 60, or 45 degrees. If it isn't, I can't use the formula I'm using within the context of what we're doing today. So here's 150 degrees gives me a reference angle of 30. It's 150. So I'm in quadrant 2. So what I'm thinking is, this is the same thing as the cosine of 45 plus 30. Those are degrees. Remembering that I'm in quadrant 2, so my cosine will be negative. All students take calculus. The cosine will be negative here. Okay. So I'm using the reference angle of 150 degrees, which turned out to be a special case angle, and I'm going to use this pattern right here. Remembering that the cosine of 30 degrees will be negative because it's a second quadrant angle. So the cosine of 45 degrees, I'm thinking of this as u and this is v. The cosine of 45 degrees times the cosine of 30 degrees, and again I'm going to remember that's quadrant 2, minus the sine of 45 degrees, u, calling that u, sine of 30 degrees. And the fact that it's a second quadrant angle doesn't really matter here because sine is positive in quadrant 2. So here we go. The cosine of 45 degrees is, cosine of 45 degrees is adjacent over hypotenuse, which would be 1 over radical 2 as above. That would simplify, we'd rationalize our denominator and get radical 2 over 2. times the cosine of 30 degrees, and it will be negative because I'm in quadrant 2. Cosine of 30 degrees is radical 3 over 2. We're not subtracting, we're multiplying by a negative. Minus the sine of 45 degrees is 1 over radical 2, which is, when we rationalize the denominator, radical 2 over 2, times the sine of 30 degrees, which is 1/2. And in quadrant 2, that's positive anyway. So I'm going to simplify this a little bit. This is negative radical 2 times negative radical 3. Remember, we're not subtracting. This is negative 2 times negative radical 3. That's negative radical 6 over 4. 2 times 2 is 4. Minus radical 2 times 1 is radical 2. 2 times 2 is 4. And I can add or subtract my numerators as indicated. That would be negative radical 6 minus radical 2. All of this over 4 if I haven't made a mistake. Okay? And it could be negative radical 2 minus radical 6 because they're both negative. The order doesn't matter. Check my answer real quick. That would be the cosine of 195. And if that's wrong, I'm going to cry. Getting ready to cry. Cosine 195, negative radical 6 minus radical 2 over 4. Yay! And I did another one. It's the same thing. I said, hey, that's 30 degrees minus 45 degrees, just like the other one was. I used this pattern, plugged in everything, evaluated them using my special case triangles, did my addition, fraction addition, and came up with this. So I'll leave that up long enough, just long enough to where you can freeze it and look at it, and you can ask me questions about it in class if you need me to. Okay, to answer. All right. Moving onward through the fog. We're going to use the tangent function this time. 285. This one ends in 5 again. So I'm going to say, well, that's the tangent of 45 plus, what is that, 240? And I want to find the reference angle for 240. So here I go. Here's 180. If I go another 60, that'll be 240. So I have a 60-degree reference angle. So I'm going to think of this as 60 degrees in quadrant 3. Put a little quadrant 3 up above it so I'll remember. This is U, this is V, this is quadrant 3. Now remember, in quadrant 3, all students take tangent's going to be positive in quadrant 3. And since all we're messing with is tangent, it's really not going to be anything I have to remember. But I do that because I'm using a reference angle. Okay, here I go. Hopefully I'm not going to make a mistake. Tangent U is tangent 45 plus tangent V is tangent 60. These are degrees over 1 minus tangent U, excuse me, tangent 45, tangent V, which is tangent 60. I'm going to make these substitutions and try not to mess up my arithmetic, and hopefully we'll be looking at the right answer. Let's take a look. The tangent of 45 degrees, going to our special case triangle. Tangent of 45 is opposite over hypotenuse, that would be 1. Oops. So this is 1. Plus the tangent of 60, I said 65 for some reason, that's 60. Why I wrote 65 degrees, we may never know. The tangent of 60 degrees is opposite over hypotenuse, so that is, I'm sorry, I said hypotenuse, opposite over adjacent, and that is radical 3 over 1. Radical 3 over 1 is radical 3. Okay, so the top of my fraction is 1 plus radical 3, the numerator. The bottom is 1 minus the tangent of 45, which is opposite over adjacent is 1, times the tangent of 60. Tangent of 60 is radical 3 over 1. So I'm going to simplify this just slightly. 1 plus radical 3 over 1 minus radical 3. And I'm going to perform this. If we were doing rationalizing binomials like this, the denominator, we would multiply the top and bottom of this fraction by the complex conjugate, not the complex conjugate, the conjugate of 1 minus radical 3, which is 1 plus radical 3. And we would do all the foiling and combining like terms and everything, but you can do that with your calculator. And I'm going to do it because this class is not about rationalizing denominators. So I'm just going to tell you what I'm doing. I'm thinking of it like this. This is very important. Parentheses, close parentheses, then hit your fraction bar or divided by, it doesn't matter. And then parentheses, parentheses. And that way your calculator will not misinterpret anything. Use parentheses when you're using a calculator. And this will hopefully give me the right answer. Here we go. It's going to be embarrassing if it doesn't. So I'm going to go parentheses 1 plus radical 3, leaving me under the radical, so I'm going to come out from under the radical and close my parentheses. Then I'm going to say divided by or the fraction bar, it doesn't matter. 1 minus radical 3, parentheses 1 minus the square root of 3, and that leaves me under the radical, so I'm going to come out from under it and close the parentheses. I hit enter, and off to the right it tells me this. Negative radical 3 minus 2. And if I haven't messed up, and I hope I haven't, that's the tangent of 285 degrees. I'll get rid of this little reference angle there. So this will be our answer if I haven't made an arithmetic mistake. Let's see what the answer key says. 285, negative 2 minus radical 3. They're both negative, so you can say negative 2 minus radical 3 or negative 3 minus radical 2. Not minus 2. They have the same value because they're both negative. It doesn't matter what order they're in because they're both negative. Okay? So negative radical 3 minus 2 is correct. Yay. And I've done another one here using the last one. I said, hey, I think of that as 60 minus 45. I set it up just like I did the one above, but the signs are different because I used tangent u minus b, plugged all this in. I said, hey, I can use my calculator to do this. Plugged that into the calculator. It told me negative radical 3 plus 2, and I guess I'll check that just to make sure. Yay, that's correct. So there we have it. You can do this.